Now let's look at some financial functions. Financial functions, as you might be aware, are functions like calculating the loan payments, calculating interest on loan, calculating installments, or computing the net present value of a certain series of cash flows, or computing the internal rate of return. So let's start with the first function, which is PMT. Before we get into understanding the syntax of the function, let's consider a small example. The example before us is of a loan of 130 million rupees. The tenure of loan is for 11 years. The rate of interest per annum is at 15%. Now, a few basics before we begin. As you might be aware, a loan has two parts, the principal and the interest. The interest is calculated on the outstanding loan balance. The outstanding loan balance is arrived at by reducing the principal payments every year or periodically from the outstanding loan balance. Principal plus interest is called the installment, P plus I. With that understanding, let's look at the PMT function, which helps us calculate the EMI, the easy monthly installment, the equated monthly installment, which is nothing but these installments. Instead of on an annual basis, they are on a monthly basis. Now, as you can see, this is a loan schedule where the opening balances are closing balances of the last year. The repayments are calculated in H in the row 31, which we will see shortly. The closing balance is nothing but the opening balance minus repayments, and the interest amount again is calculated on the opening balance. Now let's get into the PMT function. Is equal to PMT. The description for PMT is calculates the payment for a loan based on constant payments and a constant interest rate. Now in the example, the rate is 15%, so we click on rate, press F4 to make it a fixed reference, comma, NPER means the number of payments, the number of scheduled principal repayments for a loan, which in this case, let's say it's 11, which is represented by the number of years. The PV, or the present value of a loan, is nothing but the loan amount, which is 130 in this case. The optional arguments, which is FV and type, for now we can ignore. FV refers to the future value of a particular loan, and the type is an assumption of whether the principal repayment will be done at the end of the period or at the beginning of the period. By default, it is set to being repaid at the end of the period. So, this is the annual installment for 11 years to repay the loan of 130 million. This installment amount includes the interest as well as the principal amount. Now, as you can see in the example before us, the installments are being calculated on a monthly basis. So to convert this function into a monthly formula, what we need to do is the loan amount, the interest rate will have to be divided by 12. Since the tenure of loan is monthly and for 11 years, the tenure will become number of years into 12. The PV of the loan will remain the same. Let's press enter. Now as you can see, minus 2.02 is the annual installment for the particular loan. This was the PMT function. Now let's continue with this example and understand what the principal repayment each year would be in this example. For calculating the principal repayment, we use the PPMT function, which is PPMT. As you can see, returns the payment on the principal for a given investment based on periodic constant payments and a constant interest rate. Let's press tab. The rate is 15%. Let's click F4 into 12 to convert it into a monthly rate. PER means period. So let's say this is the first period and we link it with the period reference in row number 3. NPER refers to the number of principal repayments, which is tenure of loan 11 into 12. PV refers to the loan amount, initial loan amount, which is this. We press F4 again, we close. Now let's drag this formula till the end of the period. One correction, the rate to be converted into a monthly rate has to be divided by 12. And there we go. This is the principal repayment of each of rupees 130 loan for 11 into 12 periods. Let's just, for this example, extend the time up to 11 into 12. 2 periods. And there we go. As you can see, the sum of these principal repayments will be nothing but the total loan amount, which is equal to the loan amount. This is how we calculate the yearly or the periodic principal repayment for a particular loan. In the example before us, the example asks us to create a formula to compute the principal component of repayment of loan in the 56th month based on the below inputs. Now, as you saw, the formula that we used was is equal to PPMT. The rate was referred to the rate. The period is where we can specify which period we are referring to. So in the example, as you can see, the first part is the rate converted into monthly, and the second part is 56, which refers to the 56th principal repayment that we want to determine. The rest of the formula is the same, which is number of years into months. F39 is the present value of the loan, and 0 means that the interest is being paid on the closing balance. This was how we calculate principal, and this was the PPMT function. Let's move on to the IPMT function. Much like the PPMT function, IPMT function stands for interest payments. So it will compute the interest payments on a particular loan based on the inputs provided. Let's replicate the formula as we did before for the formula here, we say is equal to IPMT. The rate is 15%. Let's convert it into 12 monthly. Fixed reference it. The period reference we can draw from here. The number of periods will be 11 into 12. The present value will be 130. Close bracket, and let's copy it till the last period. Let's see why we are getting an error. We are getting an error because we have not fixed the references here and here. And there we are. This is the interest calculation on a monthly basis for the loan amount of 130. And this was the IPMT function. Now let's look at the PV function. The PV function. In the example before us, we have three inputs, namely monthly receipt, which is 4 million rupees, number of years, which is 6, and the rate of interest at 11%. Present value allows us to compute the value of future cash flows or cash flows to be received in future discounted today. So let's say if I had to receive 4 every year, or rather every month for 11 or for 6 years, what would be the discounted value today? So we say PV, which stands for present value. The description is returns the present value of an investment, the total amount that a series of future payments is worth now. We click on tab. The rate is 11%, but as you remember, we are calculating the PV on a monthly basis. So we divide the rate by 12 to convert it into a monthly rate, comma, NPER is the number of, let's say, payments or number of receipts, which is number of years into 12, which is months. PMT is the amount that we'll receive each year or each period, which is 4 million. Close the bracket and press enter, and there we have 210.15, which is the answer to our solution here also. It is the present value if we receive 4 for 6 into 12, which is 72 periods at 11% divided by 12. Let's move on to the next function, which is FV. It stands for future value. FV again, like PV, calculates the future value of what a certain stream of cash flows would be worth after the end of a certain period. So in the example before us, we are receiving rupees 4 million every month for 6 years, that is 6 years monthly, which becomes 72 payments, and at the rate of 11% per annum, which should be 11 divided by 12 to arrive at a monthly rate. Now let's look at the future value computation. Say is equal to FV tab. The rate will be 11% divided by 12. The number of periods would be 6 into 12. Remember, we are doing this for a monthly calculation or a monthly timeline. Had it been an annual calculation, we would not have needed to divide the rate by 12 or multiply the number of years by 12. The PMT is the amount received every period. We close the bracket, enter, and 405.37 or 405.4 is the future value after 72 months of this cash flow received each month from today. Moving on to the next function, which is net present value. Now let's understand the concept of net present value. Let's say we have a series of cash flow from today for a number of periods, and we need to calculate the present value of all those cash flows. We call it a net present value because some of those cash flows would be negative, some of those cash flows would be positive. That cash flows would also include our initial investment and so on. Now, there are two ways of calculating net present value in Excel, which is Excel provides us with two functions. The two functions are NPV and XNPV. There are a couple of differences between the two functions, which we will shortly see. But before that, let's see the example. The example gives us free cash flows to the firm, which is nothing but cash flows starting from year 1 up to year 15. We have the discount rate in row 118, which is 50. Now let's look at the NPV function is equal to NPV. The description provided by Excel for NPV is it returns the net present value of an investment based on a discount rate and a series of future payments. Future payments might be negative values as well as positive values. So we click on is equal to NPV, press tab. The first argument asks us for the rate. We link the first argument with the discount rate, then press comma. Now you can see there are prompts for multiple arguments starting from value 1 to value 2 and so on. Let's link all the free cash flows in the second and the arguments thereafter. We select the entire series of cash flows and then close the round bracket and press enter. As you can see, we have the NPV, which is matching to the solution provided in the example using the NPV function. Now let's use XNPV function is equal to XNPV. XNPV returns the net present value for a schedule of cash flows. Now let's look at the syntax of XNPV function. The first argument is rate, which was similar to the NPV function, so we link the rate, then press comma. The second argument also is same as the NPV function, which is the values, so we link the series of cash flows and then press comma. Now you can see the third argument was not there in case of the NPV function, whereas we have a third argument in the XNPV function, which is dates. For now, let's just link the end dates for each series of for each cash flow in the series from row 5, which gives us the end date up till year 15. Close the bracket and press enter. As you can see, we have calculated NPV using the XNPV formula. Now the two main points to note here are: 1. XNPV, the third argument of XNPV asks us for dates. This is because an NPV function assumes all of the cash flows to occur periodically, whereas the XNPV function provides an additional flexibility to convert irregular cash flows into regular cash flows. So based on the dates, XNPV will automatically determine and calculate the net present value. The second difference is, as you can see, in the calculated values of NPVs using both the functions. Using the NPV function, we arrived at a value of 103.22, and using the XNPV, we arrived at a value of 118.63. NPV function discounts the first cash flow by 1 year, whereas XNPV function does not discount the first cash flow. So essentially XNPV function assumes the first cash flow to occur at the first date of the period. So if we had to arrive at the same result using the NPV function, we would calculate NPV like this. Starting with the NPV function, we put the rate, then the values would be from the second cash flow onwards till the last cash flow, close the bracket, and plus the first cash flow. Now as you can see, the values in the NPV calculated using NPV function and XNPV are almost similar. The difference is due to the approximation difference in the XNPV function because it is calculated on dates, and NPV function because it assumes 1 year as one period. Continuing with the next example, NPV versus XNPV irregular time periods. As we already learned, NPV function will assume all cash flows to occur periodically, and XNPV function will consider irregular cash flows based on dates and convert it into annual cash flows. So in the example before us, let's calculate NPV using both the functions. The NPV function, we put the rate as 15%, comma, the values, close the bracket and press enter. Let's calculate NPV using the XNPV function. We put the rate as 15%, the values given in row 143, and the dates given in 142. Now as you can see, the dates are irregular. 1st August to 25th September is 1.5 months for 2 months. Then from September to December is 3 months, and so on. Let's close the bracket and press enter. As you can see, the values and the results from both the functions are different. This is because NPV function assumed the cash flows to occur at regular time periods and discounted each cash flow by the number of years, whereas XNPV could, based on the dates, convert the cash flows into annual figures and only discount them based on true time period concept. So this is the difference between NPV and XNPV function, and why XNPV function is a more accurate and better function than NPV. Now let's move on with our next example. In the example before us, we have the dates which are quarterly, the cash flows in row 160, and the discount rate in 161. The NPV function by default calculates NPV based on annual cash flows. So as we saw in the PMT, PPMT and IPMT functions, to convert a rate into monthly or quarterly, we divide that annual rate by the number of months in that period. So let's say if we are talking about quarters, we'll divide the annual rate by 4 because there are 4 quarters in a year. Similarly, for calculating an annual rate into a monthly rate, we'll divide that rate by 12. So in this example, to calculate NPV using NPV function, we say NPV tab the rate divided by 4. This becomes a quarterly rate, then comma, and all the values. Bracket close and enter. 57 is our answer using the NPV function. Let's use the XNPV function. Is equal to XNPV. Now, as we know, XNPV function is smart enough to determine the periodicity of the cash flows. So we don't need to convert the rate of interest in the case of XNPV function. We can simply refer the rate and the values and the dates. We close the bracket, press enter. Let's format these two cells. There is a slight difference between the NPV value calculated using the NPV function and the XNPV function, which is primarily due to the approximation of discounting. That was the calculation of NPV in case of periodic computations or when the periods are not annual. Let's move on. Now let's look at the IRR function is equal to IRR. Let's put the values, which is the IRR values, bracket closed, and enter. 192% is the solution given by the IRR function. Now let's look at the next option of calculating IRR using the XIRR function is equal to XIRR. The values will be the same, which is in row 182, and the second argument is dates. So let's link the dates given in column in row 5 only up to column V. Close the bracket, press enter. Let's format it. Let's increase it by 2 decimal places. Let's correct the formula given in the solution as well. Now, as you can see, there is a slight difference between the IRR computed using the IRR function and IRR computed using the XIRR function. The difference is because of approximation error, where the IRR function assumes each period to be 1 and an additional period is 1 plus the previous period, whereas XIRR function is calculated on the basis of dates accurate to consider while considering the periodicity. This was the IRR and the XIRR function in Microsoft Excel.